So last day we have seen three types, right? It is a supervised and unsupervised. Only the reinforcement learning, not at all. I taught. So the last type of machine learning, which is a reinforcement learning. Reinforcement learning is quite different. It is a part of machine learning where the agent is put into the environment and it learns to behave in its environment. That is a reinforcement learning by performing the certain actions and observing the rewards which it gets from these actions. To understand this reinforcement learning is, let's imagine that you were dropped off into an isolate island. Okay, that you all dropped into the isolate island. What you will do? First thing, you will be panic, right? Then you will think how to live on this island. You will explore the environment. You will understand the climate condition, right? This will be happening. The type of food, how dangerous is island, and so on. So many thinking will be there. This is exactly how reinforcement learning works, right? So it basically involves an agent which is struck on the island that is put into the unknown environment. You don't know anything in that environment. Unknowingly, you have put it in that, which is an island where we must learn by observing and performing actions that result in rewards. So, reinforcement learning is mainly used in advanced machine learning, right? Such as self-driving cars and AlphaGo. I'm sure a lot of you have heard about that AlphaGo. That is, so the logic behind AlphaGo is nothing but reinforcement learning and deep learning. In reinforcement learning, there is not really any input data is given to the agent. No input is given. All we need to do it, we has to do that, explore everything from that. Okay. And it's like a human newborn baby. You can think it as a newborn baby with no information about anything, right? The baby doesn't know anything. It's a newborn baby. Like that only the reinforcement learning works. It has to go around, it's exploring the environment and getting rewards and performing some actions which result in either rewards or in some of that any other punishment like that. So like that, you take it off. So supervised learning is already I said, the teacher is giving all the knowledge, ideas labeled, that is a supervised. Unsupervised learning, that is a genius kid. Normal kid is a supervised, genius kid is a unsupervised, right? So reinforcement means, you can think it also, keep it in your mind, that is a newborn baby. Doesn't know anything, it wants to learn, it wants to analyze, then it will give the actions, right? So this is a reinforcement learning. Here comes that is we'll discuss about the difference between these three types of machine learning. Just to make the concept you want to clear, right? These three things is very important in machine learning and artificial intelligence. First one is, see, that is a definition. The machine learns by using labeled data, right? The label, the name is given, idea is given. That is a supervised learning. Unsupervised learning. The machine is trained on unlabeled data without any guidelines. No guidelines is given, right? No clue is given about what is going to be done like that and all, right? So next, third one is reinforcement learning. An agent which interacts with its environment by producing actions and discovers errors or rewards, right? So agent which interacts with the environment, no knowledge is given, right? So by producing those actions and discovers the errors, so many errors will come, finally it will get the rewards, right? So this is a definition for supervised, unsupervised and reinforcement learning. Second thing, that is a type of problems. What are the type of problems? First one, regression and classification. It is mainly done by the classification. And unsupervised learning, this is association and clustering, the grouping, right? The Tom and Jerry will be grouped. Already in the last day we have seen, right? And reinforcement learning, this will reward based. And third thing is type of data. Which type of data we are going to use? First one is labeled data for supervised learning. For unsupervised learning, that is unlabeled data. No name is given. Reinforcement learning, no predefined data. What will happen in everything, don't know, right? So no training. Fourth one is training. It is for supervised learning, we are giving external supervision. Externally, we are giving the ideas, naming and everything. And for unsupervised learning, there is a no supervision. Here also, reinforcement learning also, no supervision will be there, right? And fifth one is approach. Which approach is given here? Map labeled input to known output. This will be the output that we know in the unsupervised learning. But in the unsupervised learning, understand the patterns and then we will discover the output, right? Here, reinforcement. Follow the trial. So many trials will be there. So many trying will be there. Then finally only it discovers and errors will be found out and finally we'll get the correct output, right? This is a reinforcement. In advanced method, self-driving cars and so many methods, they use a reinforcement learning. And popular algorithms. What are the algorithms we use under these three categories? First one is linear regression for supervised learning, linear regression, logistic regression, support vector machine, K nearest neighbor. And nowadays, so many new algorithms and all that. Basically, we use all these algorithms. And for unsupervised learning, K means C means, right? And reinforcement learning, Q learning, SASA. So all those algorithms, we use popular algorithms for these three methods. Next, we can go for types of problem solving using machine learning. In machine learning, all the problems can be classified into three types. What are they? They are regression, classification, clustering. Every problem that is approached in machine learning can be put interest on these three categories. Okay, so the first type is known as a regression. Then we have classification and clustering. So first, let's look on regression, the type of problems. In this type, the problem, the output is always a continuous quantity. Output is always continuous quantity. For example, if you want to predict the speed of the car, given the distance is given, it is a regression problem. Now, a lot of you might not be aware of what exactly the continuous quantity is, right? A continuous quantity is any quantity that we have an infinite range of values. The values will be infinite. That is a continuous quantity. One more example, the weight of a person is a continuous quantity. How? It becomes The weight can be 50, 50.1, 50.001, 50.021, like that, so on. It's going vary, right? That is a continuous quantity. Keep it in your mind, that is a weight of a person. It can have an infinite range of values, correct? So the type of problem that you have to predict a continuous quantity to make use of regression algorithm. So regression problem can be solved by using supervised learning algorithm like linear regression. Next we have classification. Now, in this type of problem, the output is always categorical value. Now, when I say the categorical value, it can be the value such as a gender of a person is a categorical value, right? Now, classify the emails into two classes, right? That you all know, that is spam or non-spam. It's a classification problem. We are categorizing. And the previously unsupervised learning we use, that is what is Tom and Jerry, that images are classified like that. That can be solved by using a supervised learning classification algorithm. Like support vector machine, naive Bayes, logistic regression, K nearest neighbor, and so on. All those algorithms you can use in classification. So again, the main aim in classification is to compute the category of the data, classifying. Next, coming to the clustering problem, this type of problem involves assigning the input into two or more clusters based on feature similarity. Thus, when I read this sentence, there is you should understand that this is unsupervised learning because you don't have enough data about your input, and only option that you have to form the cluster. With the help of cluster, we can do all those things. Categories are formed only when you know that. If I know confidently about that, then the categories will be there, right? So your data is of two types. Your input data is labeled and it's of two types. So it's going to be classification problem. But when the clustering problem happens, when you don't have much information about the input. If you don't have much information about the input, you can move for the clustering problem. All of you do, you have to find the patterns and you have to understand that data points, which is similar and clustered into one group. And data points which are different from the first group or clustered into another group. That's what clustering is an example in Netflix. What happens is Netflix clusters their users. It will first collect all those user information, then it will go in for this cluster problem. It's similar groups. Netflix clusters their user into similar groups based on their interests, based on their age, and so on. This can be done by using an unsupervised learning algorithm, like K-means, some of the algorithms that they use. So guys, there are three categories of problems that can be solved by using machine learning. So basically, what I'm trying to say is that all the problems will fall on these categories. So any problem that you give to the machine learning model, it will fall one of these categories. These three is very much important. If you do any project, if you solve any problems in your project, it will fall under these categories. Which category I'm going to solve that you want to identify. Then you can go for that algorithm. Then you can go solve with your projects, right? Okay. Now, to make things of a little more interesting, I have collected a real world data sets from online resources. And what we are going to do is we are going to try and understand the regression. If this is a regression problem or clustering problem or classification problem. Which problem is this? That we are going to understand. Now, the problem statement is here is to study the house sales data sets. Right? It's a house sales data set. And build a machine learning model that predicts the house pricing index. Now, the most important thing you need to understand when you read a problem statement is you need to understand what is your target variable. What are the possible predictors variable that you will need? The first thing you should look at that is your target variable. If you want to understand if this is a classification, regression, or clustering problem, look at your target variable or your output variable that you are supposed to predict. Here you are supposed to predict the house pricing index. A house pricing index is obviously a continuous quantity. So as soon as you can understood that, you will know that this is a regression problem. So far, you can make use of linear regression algorithm. This is a regression problem. So we are going for linear regression algorithm. And you can predict the house pricing index. Linear regression is a regression algorithm. It is a supervised learning algorithm. Let's look at the next problem. That is, here you have to study a bank credit data set and make a decision about whether to approve a loan of an applicant based on the profile. Based on the profile only in the loan and all sanctioned. Now, what is your output variable over here? Your output variable is to predict whether you can approve the loan for this applicant or not. You want to check it out. Whether I can sanction this loan. He is having the ability to every month he can pay that loan amount like that. So obviously, your output is going to be categorical. It's either going to be yes or no. Yes is basically approved loan. No is reject loan. So here that you understand this is classification problem. Okay. You can make use of the algorithms like KNN algorithm, and you can make use of the support of vector machine and so on. So support vector machine and KNN, which is a K nearest neighbor algorithm, or basically a supervised learning algorithm. Moving on to the next problem. Here the problem statement is to cluster a set of movies as either good or average based on the social media outreach. To cluster a set of movies as either good or average based on their social media outreach. This is a problem statement. Now, if you look properly, your clue is in your question itself. The question itself, the clue is given. The first line it says is to cluster, right? So set of movies as either good or average. Like that, I'm going to cluster it, group it. So guys, whenever you have a problem statement that is asking you to group the data set into different groups or to form a different clusters, it's obviously a clustering problem. Right here, you might have to use the k-means clustering algorithms, and you can form two clusters. One will contain the popular movies and other will contain the non-popular movies. Machine learning to solve the clustering problem, the regression and classification problems. The key is you need to identify the type of problem first. Now, let's move on and discuss different types of machine learning algorithm. We will discuss linear regression, logistic regression, decision tree, random forest, naive-Bayes classifier, k nearest neighbor, support vector machines. These are the algorithms of supervised learning. Let's look at linear regression first. Now, what exactly is the linear regression algorithm? So guys, linear regression is basically a supervised learning algorithm that is used to predict a continuous dependent variable y based on the values of independent variable x. The important thing to note here is that the dependent variable y and the variable that you are trying to predict is always going to be a continuous variable. But the independent variable x, which is basically the predictor variables, these are the variables that you will be using to predict your output variable, which is nothing but your dependent variable. So your independent variable or your predictive variables can be either be continuous or discrete. Okay, there is a not such restrictions over here. They can be either continuous variable or they can be either a discrete variable. Once again, I tell you that the continuous variable is, in case you have forgotten, it's a very, that the infinite number of possibilities will be there. So I'll give you an example of the person's weight. It can be 160 pounds or it can be, the weight will be 160.11 pounds like that, or 160.1134 pounds like that. It will be varying on and so on. So the number of possibilities for weight is limitless. And this is exactly what a continuous variable is. Now, in order to understand the linear regression, let's assume that you want to predict the price of the stock over the period of time. For such a problems, you can make use of linear regression by starting the relationship between the dependent variable, what and all it is dependent like that, which is a stock price, and the independent variable, which is in time. You're trying to predict the stock price over a period of time. So basically, you're gonna check how the price of the stock varies over the period of time. So today the stock will be with some rate, and after 1 week, it will be varying, right? That you all know. That's coming here. So your stock price is going to be your dependent variable or your output. As I said, your output variable, and is the time is going to be your predictor variable. Time is very important. Don't confuse. Your dependent variable is your output variable. That is the main thing. Dependent variable is the output variable. Okay, your independent variable is your input variable. Got it? So dependent variable is your output variable and your independent variable is your input variable or your predictor variable. So in your case, the stock price is obviously a continuous quantity because the stock price can have an infinite number of values. Now, the first step in linear regression is always is to draw the relationship between your dependent and non-independent variable. We make an assumption that your dependent and independent variable is linearly related to each other. We call it linear regression because both the variables vary linearly, which means that plotting the relationship between these two variables will be get more of the straight line, right? Instead of a curve, here there is a straight line is happens, right? So let's discuss that. Behind this, what is it? Behind this method, there is a linear regression is present. So this equation over here, it denotes here the equation is there. It denotes the relationship between your independent variable x, which is here your dependent variable y. This is a variable you are trying to predict. Hopefully, we all know that the equation for the linear line in maths is y is equals mx plus c. I hope all of you remember that math equations for the linear line. Math in is y maximum and equals to mx plus c. Similarly, linear regression equation is represented along the same line. Okay, y is equal to mx plus c. There's a little bit of changes, which I'll tell you that let's understand this equation properly because this is one important algorithm. So y, first you can take it out, y. Y is basically stand for your dependent variable that you are going to predict. B naught or beta naught is a y-intercept. Now, y-intercept is nothing but this point. Beta naught is a y-intercept. Now, y-intercept is nothing but the which is a point, some of the main point of this. And now in this graph, you're basically showing the relationship between that dependent variable y and the independent variable x. Now this is a linear relationship between these two variables. Now, that is a y-intercept is basically the point on the linear which starts at the y-axis. This is a y-interceptor which is represented by b naught. Now, b1 or beta is a slope on this line, right? There is a slope. Now, the slope can be either negative or positive, which is depending on the relationship between the dependent and independent variable. The next variable that we have is x. X here represents the independent variable that is used to predict our resulting output variable. Basically, x is used to predict the values of y. E here denotes the error in the computation. If you do anything, any problem, there will be error will come. You want to solve it, right? So here E represents that error in the computation. For example, this is the actual line, and these data here represents predicted values. Now the distance between these two is denoted by error in the computation. So this is an entire equation. It's quite very simple, right? Linear regression will basically draw a relationship between your input and the input variable. That's how simple linear regression was now a better understand. That is a very easiest one, that is a linear regression algorithm. Next one is logistic regression. Logistic regression. Now, in order to understand why we use this logistic regression, let's consider small scenarios. Let's say that your little sister, for example, you can take it as, is trying to get into grand school, top school. And you want to predict whether she will get admitted in her dream school or not. Okay, so based on here, based on the CGP, which she scored on the past data, you can use logistic regression to force the outcome of. So the logistic regression will allow you to analyze a set of variables and predict the categorical output. Since here we need to predict whether she will get into school or not. With the help of logistic regression, you can predict, which is a classification problem. Logistic regression will be used. Now, I know the first question that you are thinking in your head, that is why we are using this using linear regression in this case. Why you're not using, right? We are not using linear regression. The reason is that linear regression is used to predict a continuous quantity rather than a categorical one. Got it? Continuous quantity, the weight you can take it out. That is it will be varying, right? That comes under linear regression. But in logistic, it is a categorical one. Whether she will be admitted based on her CGPA or she will not be admitted. So here we are going to predict whether or not your sister is going to get into the dream school. So that is clearly a categorical outcome. So when the result is outcome, you take only the classes of values, like two classes of values. It is sensible to have a model that predicts the value as either 0 or 1, or in a probability form that ranges between 0 and 1. So linear regression does not have this ability. If you use a linear regression, the model that is a binary outcome, the resulting model will not predict the y values in the range of 0 and 1, whether it will be 0 or 1. Because linear regression works on continuous dependent variable and not a categorical variable. That's why we make use of this logistic regression. So understand that linear regression was used to predict the continuous quantities. Logistic regression is used to predict the categorical quantities. Okay, now one of the major confusion that everybody has, that is why it is called logistic regression. What is the use for classification? The reason is the name logistic regression is because its primary technique is very similar to logistic. So that it called like that. And it belongs to the same class as linear regression. Logistic regression mainly used for classification problem. Because here you will have to predict a dependent variable, which is categorical in nature, and so is mainly used for classification. Logistic regression is a method used to predict a dependent variable. Dependent variable y, and which is given an independent variable x, such that the dependent variable is categorical, meaning that your output is a categorical variable. So obviously this is a classification algorithm. Now, how does the logistic regression works? Look at the graph. Now I told you that outcome is a logistic regression is a categorical. Your outcome will be either 0 or it will be 1, right, sir? So it will be a probability that ranges between 0 and 1. There is a probability between this, the value will be that. So that why we have this yes curve. Here you are seeing yes curve, right? It will be, the value will be between zeros and 1. That's why we are here, it is formed as a yes curve. This is known as a sigmoid curve. It's called a sigmoid curve because you can have the values ranging between 0 and 1. That's why it's called a sigmoid curve, which will basically shows the probability. Maybe the output will be that is 0.7, 0.5, like that, which is a probability value. If it is 0.7, it means that your outcome is basically 1. So that's why we have this sigmoid curve like this. Another thing, it's a very interesting because this is a very simple to understand. Now let's discuss about the decision, which is again the classification algorithm. Decision tree is a supervised machine learning algorithm, which look like an inverted tree. Very interesting one, that is a decision tree, wherein each node represents a predictor variable. And the link between the node represents a decision, and each leaf node represents an outcome. So let me ask you to understand that is a decision tree is with the help of an example I'll explain you. Let's say that you hosted a huge party, right? You hosted a huge party and you want to know how many of your guests were non-vegetarian, how many of your guests are vegetarian, that you want to know. So to solve this problem, see the figure, I have created a decision tree that classifies the guests either vegetarian or non-vegetarian, like that. Finally, it will give the answer. Last outcome here is non-veg or veg. This is a classification algorithm. Because here you are predicting a categorical value. Each node over here represents a predictor variable. So each chicken is one variable. Each mutton is another variable. Each seafood is another variable. 3 variables I have taken. So each node represents a predictor variable. that will help you to conclude whether or not a guest is non-vegetarian or vegetarian. As you traverse down the tree, you will make decision that each node until you reach the dead end. Okay, that's how it works. Up to the starting to end, it wants to go, move on. So let's say we got a new data point. Now we will pass through the decision tree. First variable is, did the guest eat chicken? If yes, he or she is a non-vegetarian. If no, then you will pass it to the next variable. Why did the guest eat mutton? Did the guest eat mutton? If yes, it goes to the non-vegetarian category. If no, it automatically moves to last variable. Did the guest eat seafood? Then here also it's checking on whether yes, non-vegetarian, whether no means finally veg. This is how the decision tree works. It's a very simple algorithm. That's why we can easily understand this. In many of the starting stage, if we start any projects, mostly the people who choose this decision tree algorithms can easily solve it. We can do it very fastly like that. Now let's understand the structure of the decision tree, right? So I just show an example of how the decision tree works. First of all, we have something known as a root node. Root node is important. The root node is the starting point of the decision tree. Here you will perform the first split. The split into two other nodes or three other nodes. Depending on the problem statement, we can categorize this. So on the topmost node is known as the root node. So this is a root node. Did the guest eat chicken? The root node is assigned to the variable that is very significant, meaning that variable is very important in predicting the output. So you can assign a variable that you think is the most significant at the root node. After that, you can know something known as that internal nodes. All those are internal node. So each internal node represents a decision point that eventually leads to the output internal node will have other predictor variable. Each of these are nothing predictor variable. Terminal node is also known as a leaf node that represents the final class of the output variable. Finally, what is happening? Final output, that is called as a leaf or terminal nodes. Branches are nothing but connections between the nodes. Okay, actually these connections or links between each node is known as a branch, and they are represented by arrows. So each branch will have some response, right? Either yes or no, true or false, 1 or 0, and so on. So many things we can represent for the answers. So this is a structure of the decision tree. It's a pretty understandable. Next, ID3 algorithm, which you use in decision tree. It's just a concept behind the behind this decision tree. That is ID3 we call it as. This algorithm has around 6 defined steps in order to build a decision tree. With the help of ID3, I'm going to build a decision tree. ID3 algorithm, I'm going to build a decision tree. ID3 has a 6 steps, right? So step 1, select best attribute. What is attribute? Attribute is a predictor variable over here, which you are going to predict. So you will select the best predictor variable. Let's call it as A. After the best attribute predicting is completed, step 2. Assign A as a decision variable for the root node. Basically, you will assign this predictor variable A as a root node. Step 3. Next, you will do it for each value of A. You will build a descent intent at the root node. Now, these 3 steps, let's look at it. These 3 steps will be done. And next one, just think it out, these 3 steps with the previous example. Now, here is the best attribute is each chicken, right? And step 4. You can think it out, this one. For that algorithm, we can implement here. First one is root node, right? So we will check it out. Each chicken will be the best attribute. Step 4. Assign the classification labels to the lead node. Step 5. Whether the data is correctly classified. You got the output, correct output. You can stop the working. Yes. Iterate over the tree until you reach the final goal, correct output. Iteratively, these 3 operations will be executed n number of times. Keep changing the position of predictor variable in the tree, or you can change the root node also. You want to get the correct result, right? You can change any values in the root node or predictor variable like that until you get the correct output. Now, let's tell me the answer for this question. That is the best attribute. What is the best attribute? What do you know mean that is a best attribute or best predictor variable? Now, the best attribute is one that separates the data into different classes most effectively, or it is basically a feature that splits the data set. Based on the feature, it splits up. Now, the next question is, how do I decide which variable is best to split the data? How I can think it out. To do this, there are 2 important measures. There is something known as the information gain and something known as a entropy. Now, guys, in order to understand the information gain and entropy, we look at a simple statement problems. The problem statement is the data represents the speed of the car based on the certain parameter. So our problem statement here is to study the data sets. Here the small data set I have taken and create a decision tree that classifies the speed of the car and either will be slow or fast. So predictor variable here are road type, obstructions, that is a speed limit, whether it will be step, steep or flat. So you will be building a decision tree using these variables in order to predict the speed of the car. All right, I already explained to you that we must first begin by deciding a variable that splits the data set and assign the particular variable to the root node and repeat the same thing for the node as well as. So step 1 is want to choose a best attribute, right? So how do you do? Which attribute separates the data? The variable with the highest information gain derives the data into the desired output classes. First of all, we will calculate the 2 measures. We will calculate the entropy and the information gain. Now this is where that what exactly entropy and what exactly information gain. Now, entropy is basically used to measure the impurity or the uncertainty present in the data. It is used to decide how the decision tree can split the data. That is the entropy. Information gain, on the other hand, it is a more significant measure which is used to build a decision tree. It indicates how much information a particular variable gives you about to find the final outcome. So information gain is important because it is used to choose a variable that splits the data at each node for the decision tree. Now, the variable with highest information gain will be used to split the data at the root node. Now, in our data set, there are 4 observations. You can see here. So what we are going to do, we'll start by calculating the entropy and information gain for each of the predictor variable. In our data set, you can see there are 4 observations. All those 4 observations is a row type column, which corresponds to the 4 labels in the speed columns. So we are going to begin by calculating the information gain of the parent node. The parent node is nothing but the speed of the car node. This is our output variable, correct? So it will be used to show whether the speed of the car is slow or fast. To find out the information gain of the speed of the car variable, we'll go through a couple of steps. Now, we know that there are 4 observations in the parent node. First, we have slow, right? You can see here speed, slow. Then steep, that is a slow. Then fast, right? So, out of these 4 observations, we have 2 classes. The 2 observation which is belongs to slow and 2 observation which is belongs to fast. That's how we want to calculate the P slow and P fast. P slow is nothing but a fraction of slow outcomes in the parent node. P fast is nothing but that is a fraction of fast outcomes in the parent node. The formula to calculate the P slow is, you can see here, there's a number of slow outcomes in the parent node, which is divided by the total number of outcomes. Here you can see that how to calculate the P fast. The number of fast outcomes in the parent node, which is divided by number of outcomes, total number of outcomes. So 2, which is divided by 4, the answer is 0.5. Now you will get the answer of 1. So the entropy of your parent node is also 1. After calculating the entropy of the parent node, you will calculate the information gain of the child. Here you want to apply in this formula, you want to apply the entropy parent, then you will find out the answer is 1. This is a formula for finding out. So guys, remember that if the information gain of the road variable is greater than the information gain of other predictor variable, only then the root node can be split by using a root type variable. The root node can split all those things, root type. So to calculate the information gain of row type variable, we first need to split the root node by using a row type variable. Now the entropy of the right hand side is 0. Entropy is nothing but the uncertainty. There is no uncertainty over here. If you see the flat, suddenly it moves to the past, right? Only for flat, fastly it will be going on. For steep only, there is sometimes slow, sometimes fast. So there is no uncertainty in this flats. Because as soon as we can see that the road type is flat, your output is fast. So that there is no uncertainty. But the road type is steep. Any one of the output, either it is a slow or it can be a fast, right? So start by calculating the entropy of both right hand side and left hand side of the decision tree. So the entropy for the right child node will be 0. So there is a no uncertainty. Left child node, there is a lot of uncertainty. Whenever the road type is steep, your output can be either slow or fast. In order to calculate the information gain, apply the formula. That is minus the weighted average into the entropy of the child. This formula you need to calculate of all of these values. So first of all, you need to calculate the entropy of the weighted average. Now, the total number of outcomes in the parent node is 4. That you know, that is totally the parent is giving 4 outcomes, right? So here 1, 2, 3, and 4. And the total number of outcomes in the left child node, you can see here, left child node gives 3 outputs. So outcome is 3. And the total number of outcomes on the right child node is 1. All those things you want to substitute in this formula. We will get around the weight will be 0.675. Finally, the information gain for the row type is 1 minus 0.675, which is equal to 0.325. That is, you want to apply for this formula, information gain is equal to entropy parent minus weighted average, and finally it is multiplied by entropy of children. The speed limit gives you the maximum information gain. The information gain speed limit is 1. So we find it out, the decision tree, the information gain value. Like this way, you can calculate the decision tree. So within this time, I have conclude this. Really, I thank the management of Chalapati for giving me this opportunity for explaining about